So today we're going to look at how to analyze data that has two variables. That's what bivariate means, two variables. And let's first look at some of the data that we have looked at in the past. So here's that ozone hole layer data and how big that ozone hole is over time. And we can see that it says here in 1987, several countries agreed to take action and protect the ozone hole layer because they saw it was a problem, right? They looked at data and they realized it was a problem. The goal of this international treaty, called the Montreal Protocol, was to limit and eliminate human made substances that harm Earth, for example, CFCs that were found in refrigerators and hairsprays. The scatter plot shows the average size of the ozone hole over Antarctica over several years. Make a prediction for the area of the ozone hole in the year 2030. So again, 1987 is about here. And you can see that a law actually made a difference. There was a law put in place, a treaty, where countries agreed to stop producing these CFCs and these other harmful chemicals. And not right away, right? It took some years, but eventually it did stop going. You can see from here to here, it went up 10 million square kilometers in only about 5 years. And then it still went up about 10 in about 5 years. But then it only went up about 5 in 5 years. There's the slope, right? How much it goes up and how long it takes. And then it almost didn't go up at all for a couple of years. It stayed at about 25 million square kilometers. And you can see now it almost has a negative slope. It's going down about 5 every 5 years, if you can kind of see that trend line there. So the question is, what would be a prediction for the area of an ozone hole in the year 2030? Now, whenever I'm making a prediction, I like to think of um, uh, a prediction that's way too high and a prediction that's way too low, and then just so I can kind of get a sense of where that actual answer should be. So here's 2010. It's about 20 million square kilometers in 2010. 2020 is now. We don't have the latest data. You could guess somewhere around here, maybe. And then 2030 is over here somewhere. So you have to try to think, where might this be in 2030? That's going to be your first task with your group. And you might have some disagreements, but hopefully you can kind of come up with a range and at least an idea of whether it's going down, going up, or about going to stay the same. Then we're going to start looking at some other science data, because again, data is for the environment, it's for grades, it's for sports, it's for all sorts of different things. So we're going to look at this question. So this is a question that you can kind of talk about with your group. Do you think heavier animals have heavier brains? And that's an opinion question based on maybe some experience or some background knowledge you have. Don't worry about being right or wrong. It's just kind of getting you thinking. Then when you get to slide 4, you're going to start thinking about how to actually answer that question. And one way to answer it is by looking at a visual, looking at a graph. So it says the table shows the data of body weight and brain weight for several animals. Now, they didn't pop up the table, so it's hard to tell. So I'll just let you know this is going to be body weight is going to be on the x-axis or the horizontal axis. And on the vertical axis, it's going to be brain weight. And there's the table for you right there. So here you can see, here's different animals. Giraffe, which is Tamika's favorite, by the way. Tiger, goat, and cow. So you had the body weight of a giraffe is about 529. That's on the x-axis. 529 is about here. And its brain weight is about 680 grams. 600, 900, so this must be, I don't know, about 750. So 680 is down about here. So about 529, 680 is about there. So I'm going to take the giraffe and I'm going to move them down about here. All right. And then you're going to plot yours wherever you're going to plot them. Obviously, those are wrong. I'll just do that quickly. But you can kind of look at the tiger, the goat, the cow, their body weight, brain weight, their X and Y. And then you check your work, and then it'll actually tell you where they should go. Then, once you have all that data plotted, and they give you some other data, these are some other animals, And you can kind of see that as the body weight increases, you can see the brain weight seems to increase, which makes me think it's a positive association. Now, you could argue whether it's a linear association. Is there kind of a line you could draw through there? No, that's something you guys can discuss in your groups. And then once you kind of have this pattern here, you can start to predict maybe if you don't have the brain weight. If you don't have the brain weight, could you kind of figure it out? Well, here's a dog. It says a dog is 10 kilograms of body weight. Here's 100, 10, 20, 30. So 10 is like way down here. Oh, it tells you there's a cat, a monkey, another kind of monkey, a goat, a wolf, a sheep, a lion, a tiger. So I'm gonna put the dog like way down here, and if he's that small, he probably has a small brain weight. Then you do the same with a pig. Pig is 192 kilograms, which is like up here. So you kind of figure out, well, I don't know, he's made probably around these guys, right? And then you just kind of figure out what you think. And then once you do it, I'll just put that in a wrong random place. You check it, and then it'll actually tell you where they should go. Once you get to that, you'll be practicing your checking lines to fit, and it'll tell you if you got it or you didn't get it, if you need to retry. And then we have another opportunity. Now we have a line. Now we can actually use the line to kind of predict, okay, the gorilla is 207, so maybe put him there. You know, if he's 207, I'm going to guess he must be kind of near the line, right? Or who's this guy? This is a jaguar. That's kind of cool. He's 100, so he's probably around there. Right? And there's the human. He's 62, so he's probably around there. And you're going to check it and see what you learn from it.